I could welcome you back to our screens by the magic of the internet, and thanks to my colleagues in the background. And for those more observant in the audience, you'll realize that all of our presenters have managed to magically change their clothes, and it's now dark where Anna Maria is. So yeah, a little trickery there. They were pre-recorded presentations, which is good because you can also rewatch them. They're available on the website, so feel free to go back. And thanks also for including the references. Just for your information, C2G also produces, we have an evidence brief on this, which contains many of the references that the speakers referred to. You can download that from our website and find out more there as well. So now we'll move on to the Q&A session. Just a couple of quick clarifications. Doug, in your presentation, you mentioned something about an additional 1% of sunlight reflected would be more than enough to offset all of the emissions of CO2 we've added to the planet so far. I presume by that you're referring to would be enough to offset the impacts of global warming and climate warming rather than the emissions. Is that right?
Well, I actually meant specifically the global mean temperature change.
Right, gotcha. Yeah, just
if you want to talk about the impacts, that's actually, you know, a 5-minute question, not a 10-second question.
Sure, and maybe we'll get to that shortly. So, okay, thanks for clarifying. And just for the sake of our speakers and the audience, there's obviously you heard about sort of three or more main ideas here for solar radiation modification approaches, all of which are largely theoretical at this stage. When asking your questions, or indeed speakers when you're responding, maybe could you make clear whether you're talking about SRM more generally or specific approaches such as stratospheric aerosol injection, which was mentioned by several of you quite specifically. So there are lots of knowledge gaps. There are governance gaps. We need to know more. We're fortunate in that it's quite a smaller group in the audience today, so lots of opportunity to ask your questions and actually get a chance to have them answered by our three very experienced panelists here. So if you have a question, please submit it via the Q&A box, not the chat box, as sometimes happens. Just hit the Q&A button, send the question in, and colleagues will relay it to me and we'll try and get through them. We already have a first question here from Thibault Lemail. Sorry, Thibault, hope I pronounced correctly there. And this is around research and uncertainty and risk. I don't know who would like to take this first. Maybe Doug, this is one for you to kick us off with. Are there efforts made to systematically quantify sources of uncertainty in the SRM scenarios that you're aware of in order to determine sort of the degree of confidence? How much can we be confident? How much do we know? Or is it the range of error quite wide and it's a bit of a large degree of guesswork at the moment? What can you tell us about what we know from the research to date on that?
So first of all, I'd say thank you for the question, because that's actually a perfect question, and that's if you looked at sort of my own list of here's the research questions I think are most important, that's basically one of them. Is that typically people have sort of taken a climate model and run the climate model and said, well, here's what we think happens in this climate model. And we have not really done a very good job at all of saying, what's our confidence in that? So if you want to make informed decisions, you need to know both, here's what we think will happen and how uncertain that is. And even if you want to sort of say, here's what research we would need to do to improve our confidence, you need to be able to say, well, okay, this is the driving factor in our uncertainty, or this is, or, yeah, this thing's uncertain, but we really don't care about it. It doesn't affect predictions. And then coupled in with all of that is you need to understand something about how well research can reduce uncertainty. And we know that there will be some level of irreducible uncertainty without actually deploying something. But we don't actually know what that level is. So there's actually a bunch of coupled questions in there. The answer is this is something that we really need to do a much better job of, is to really systematically quantify the uncertainty and say, for stratospheric aerosol injection, we need to understand our aerosol microphysics better, because the observations we have after volcanic eruptions aren't sufficient to constrain those parameters. And here is how we would go about doing research to reduce that. So that sort of thing needs to happen.
Okay, thanks, Doug. Thelma or Anna Maria, would you like to come in on that question as well? Or?
Well, I will come quickly on that one, because I think that Doug has covered quite nicely. So most of the understanding that we have on the SRM methods, in particular, you know, the stratospheric injection, which is the most researched one, are being carried out in laboratory. So the reality is still, you know, going out and having experiment and testing outside the laboratory might be different. We don't know. But I would like to say that I was looking at my notes also about this experiment of the geoengineering model intercomparison project, the GeoMIP. And the GeoMIP was, you know, was studying in particular the potential implications of determination shock of the SRM. So, so you see that there are a lot of research going on in particular methods of the SRM, not all of them, as I already said, and with different also implications. So because this is done basically using models and including the geoengineering model intercomparison project, it uses 11 models. So from these, you can see consistency in the results. And obviously they can come up with some of the potential implications of some of the methods. But you know, I think that because some of these, you know, testing in laboratory would be ready to go out to be tested outside the laboratory conditions, really pushes us to think about regulatory frameworks of, you know, what can be tested, how it can be tested. So there is a whole lot of things that need to be better understood and better framed so that there is a, let's say, a broader understanding of the potential implications of testing, you know, these methods outside the laboratory realm, I would say.
Thank you, Thelma. And I might put you on the spot, Anna Maria. I know you've done a lot of work in the past around research governance, haven't you? Anything to add specifically on that, on the importance of research governance in relation to SRM?
Well, I might just add that more research won't necessarily make the issue less controversial. And that's something I think that is often overlooked. So there is social science research that points out that yeah, values and perspectives weigh very heavily in these debates, and these can't be resolved by simply providing more information.
So if I've got another question here from another event we had, which seems timely now, so I'll throw this in here perhaps for you all, which is, so what's the importance of research for governance, you know, so compared to sort of, we need to know some more information in order to design governance regimes. We need to fill some of these knowledge gaps. So what's the role of research here in terms of shaping governance and in terms of applying governance down the line as well? Any thoughts on that from any of you? Thelma.
Yeah, let me do this. And also let me clarify, Nick, that, you know, when I'm doing these interventions, I might be, you know, bringing some of the research outside what I see in the IPCC. Not that I am not in accordance with the assessments of the IPCC, but because sometimes there are other things happening more timely that IPCC could not pick up in terms of the literature assessment. Then I would like to to clarify this. Well, research is absolutely important, but Anna said it's not enough. But what I would like to say is the importance of a more inclusive research on these issues. And what do I mean by that? Well, most of the research on the methods, not too many on the other methods for SRM, but you know, the stratosphere injection, as we have already mentioned, are done in developed world because they have more money, they have a more coordinated research groups. So in my vision, the research needs to be amplified, and in particular because the potential effects of the deployment of SRM is going to be regionally different, regionally distinct. So countries want to know, and they have to know, I would say, what would be the potential implications regionally, and it would be even better if it could be locally, right? So changes in the precipitation patterns, for instance, the monsoon, changes in the monsoon. So we see that because of the different impacts regionally, it is really important to broaden up the research so as to motivate others. How we do this, we might discuss in another question, but how to pull researchers from a much broader community, research community around the globe, so that their concerns could also be responded by the science. So I think that this would be my goal, to tell you how research on this topic and governance of research would basically try to do what I'm saying, to pull together different research communities around the globe and broaden the research topics to be addressed by these research groups.
Great. You raise a very interesting point there, and I'd like us to come back to that, if I may, and just perhaps come back to see Doug or Anna Maria. So is the research into the potential impacts of SRM important for its governance, and if so, why and how? Any thoughts on that one? Or indeed, we can move on to the issue that Thelma raised as well. Anna Maria, would you like to go ahead?
Yeah, I mean, just returning to the previous question, there is some debate in the literature about, we have this chicken and egg effect. Should we start with governance? Should we get on with the research and then develop governance based on what we know? But I think what's emerging in the literature is this idea that the two should develop in tandem. And so a lot of the work on governance of research has looked at the development of general principles and mechanisms that should guide the research effort. And this includes things like Thelma mentioned, broadening out participation both within domestic jurisdiction, but also internationally. So promoting cooperation and coordination of research at an early stage. And so over time, as we research different technological proposals, we can elaborate these principles in a more specific and contextual way. But I personally think that there is, we don't need to reinvent the wheel here. We have lots of experience governing other kinds of emerging technologies, and we have knowledge of the kinds of principles and mechanisms that are important to guiding their development in a democratically accountable way. So that's my view.
Great, thanks. Thanks.
Can I just add one?
Yeah, Doug, go ahead. Sure.
Very quick point is just to say, when we talk about research, that's not just research into the physical climate system and how that affects, right? There is also research that needs to be done on the social science, on the governance, on the ethics, and so forth, right? Just from like trying to understand how different cultures and different stakeholders are likely to view different types of risks and uncertainties. That research broadly hasn't been done well enough, and that type of work also will inform our governance considerations.
Great, you raise a very interesting point there, Doug, and actually that reminds me of there's the parties to the Convention on Biological Diversity have noted this need over several years for more transdisciplinary research, as you're alluding to there, and Anna Maria alluded to as well, and I think Thelma too. So let's dig into that a little bit more. What kind of research might this involve, and what kind of knowledge gaps and questions do we need answers to specifically to inform our better governance of these approaches or technologies? Thelma, do you want to come to that, or?
I wanted to complement a little bit our response, because when we think about international governance, and you touched in one point about the Convention on Biological Diversity, but not related to SRM, this, solar radiation modification, but we saw that international governance really came very early into play for CDR, and especially for marine engineering that included ocean fertilization. So we are talking about, much before we are in 2020, that, biological diversity was in 2010 when they mentioned that, member governments, should not deploy, any methods that in ocean fertilization in particular that could put at stake biodiversity. But we see that the international governance on marine engineering that includes ocean fertilization is regulated under the amendments of the London Convention and the London Protocol on the prevention of marine pollution by dumping of wastes and other matter. So they only allow legitimate scientific research, but not deployment. So we say that we are talking about, governance that has started long ago, but more specifically on carbon dioxide removal methods, but nothing on SRM, not that I know of.
Okay. Anna Maria, any thoughts on that, or Doug, or on the transdisciplinary research issue?
Well, the term in the London Protocol is marine geoengineering, and it's actually not specific on the point of CDR versus SRM. And so, for example, there's a little bit of literature on the fact that ocean fertilization could be used to enhance marine clouds and so forth. So that's sort of splitting hairs on a legal technical issue. But I think the ocean fertilization regulation and how it developed is maybe indicative of how we might expect other forms of governance to emerge at the domestic and international level. So we talk about this like we're planning incrementally in an irrational way regimes, but for governing certain kinds of technologies. But we see through the ocean fertilization example that often governance emerges spontaneously and in an ad hoc manner. And quite quickly in the case, when we compare other kinds of international law and developments in the context of marine geoengineering, the issue is if we see this kind of spot reactions in different fora and different legal frameworks, do we potentially create conflicting rules and so forth? And so the issue of fragmentation of international law or the fact that we don't have a sort of consistent framework for addressing SRM issues could crop up as an issue in the future.
Okay, great. I'm going to ask, we've got a couple more questions coming in, but our audience keep sending them in. No questions too foolish or stupid. There's a lot of technical issues being dealt with here if you're new to this topic. So ask away. Even a very simple question is fine. There was a question raised about, is SRM a one-way street? So how risky is it to implement SRM before addressing all the risks, considering that temperatures may jump even when the SRM is then terminated, and what are the risks of potentially indefinite SRM? So a few questions bundled in there. Who'd like to, anyone like to respond on that?
So I'm happy to start on that, and I'm sure everybody else might jump in as well. But so really, I guess there's three things buried in there. So first, no, it's not. You can always stop. And then of course there's consequences to stopping as well. The second observation is that it's always in context with what the other risks are, right? So what are the risks of not implementing SRM, and how severe are those expected to be? And that depends both on how aggressive we are at cutting our emissions and on uncertainties that we currently don't know in the climate system. And then the third observation would be that the specific to the termination risk, that obviously depends on how severe that is, depends on how much you are doing. And if you're imagining a deployment that is gradually ramping in, if you actually were to like suddenly start cooling the planet by a degree, that actually would be really bad. You don't want any like really abrupt transitions. So if you're gradually ramping things in, then by the time that you are putting enough in, cooling the planet enough where the termination shock would be really severe, you presumably have had some time to learn about what the consequences are and at lower forcing levels and potentially phase it out if you want. So from a purely physical climate, like if you had an ideal governance situation, then I don't think that you would ever run into an issue with termination. The issue with termination is much more one of, political will changes, wars, whatever, and people stop implementing it. The final thing I want to add there is there's risky. Are we talking about physical climate risks, or are we talking about societal risks of conflict and so forth?
Interesting question. That actually reminds me of a great graphic I recall in the IPCC's 1.5 degree report, which compared the relative risks between 1.5 degree scenario and a 2 degree scenario, which is, again, you have to compare these risks. And a very interesting point you raised there, Doug. Thelma or Anna Maria, would you like to come back on that question?
Yeah, I can complement. Obviously, solar radiation modification point of view of the IPCC is sought to complement, if necessary, in particular for overshoot pathways that were explored and assessed in the 1.5 special report. So they are complementary to very ambitious mitigation efforts with big emission reductions, and also even after you have the CDR. So it's basically coming in a certain order there. Ambitious mitigation efforts, the efforts to remove CO2 from the atmosphere for reasons that we explore when we are in the session on CDR, on carbon dioxide removal. So it comes, as basically a method or an approach to situations where we are in an overshoot and trying to really minimize the impacts of the rise in the global temperature, average and temperature. Yeah, I think Doe has mentioned the termination effect, which is very much explored or assessed in the IPCC as one of the potential risks of SRM. But obviously, as Doe has always said, there are conditions that might lead to more or less risks of the termination of SRM. I think that it depends very much on the how much here is being injected, how much of the cooling effect was from the application of SRM. So there might be some risks there, in particular for biodiversity. I think the IPCC makes that very clear. But essentially, we see them also because of the differentiated risks of SRM regionally. Is that what brings more concern, I would say, on the SRM. But obviously, as we have already mentioned before, a lot of research is still to be carried out, and obviously new results will come up, more research will be carried out with broader research groups, hopefully, and hopefully some of these aspects will be with less uncertainty than we have today.
Thank you, Thelma. Anything to add there, Anna Maria, or should we move on? We've got another question we can move on to about.
I would just add that at this point, it's really difficult to answer the question of how risky, because there's a large amount of uncertainty here. And so, for example, you see this comparing the risks of climate change against different SRM techniques. And we're really comparing climate risks where we have observational data and so forth against mainly modeling data. And I think it's not a comparison that you can easily set up, especially given the sort of social, political, ethical, and other issues that surround both of them. So the other thing is risks for whom, where, and so forth. And so risk is partly a perspective, an issue of values and perspective. And it's also not this sort of, it's, you know, we talk about it in terms of a global sort of phenomena, but really I think it depends on, you know, where you're living, how you perceive risk, what you value, and so forth. And so that weighing up exercise is entirely contextual and depends on the party that's doing the weighing. So it's really hard to answer that question. And finally, yeah, governing the termination effect would require some sort of mechanism that ties mitigation ambition and fulfillment of that ambition against SRM deployment. And we certainly haven't worked out how that would work. So challenging.
Mm-hmm. Great, and a very important point you raised there, the distinction between modeled data or observed data as a basis for our understanding. Very important clarification when assessing such potentially large risks. I want to move on. We've been talking a lot about research, and that's great. We have another question, and I want to go back to something you mentioned in your presentation, Anna Maria. This idea of green finger sounds like some kind of movie villain. And I believe that this risk of unilateral deployment of SRM was also referred to in chapter 4 of the special report on 1.5 degrees, the IPCC published in 2018. And this relates to this question. It's about because the effects will be international in nature or global in nature. Therefore, the governance needs to be fit for purpose in that sense. And so we have a question here from Huzhu Wu. Apologies, Huzhu Wu, if I pronounced badly. The problem might be that not all countries agree to do SRM testing or deployment that's in a common space, i.e. on the high seas or in the stratosphere. How to deal with this situation? So how do we resolve this need for governance of something that may be deployed by a single actor in one place, but will affect everybody globally? Any thoughts on that? Or what do we know about this from the thinking that's been done around this topic? Because it's an important one.
Yeah, so certainly with technologies like SAI, which are by nature global in their effects, we have this issue where it's in economics terms, in global public goods thinking, this idea of a single best effort. So one country could potentially have the technical and financial resources to implement unilaterally a deployment of SAI. And so the issue here in the incentive structure is not the issue that you can't make this happen. We have a very different problem in climate change where it requires an aggregate collaborative effort by all countries to reduce their emission. We don't have that problem here in terms of governance. The issue is that other countries may not agree with this kind of action, and it's very difficult to stop it. And so that's a very different governance scenario. And I think under the current international framework, if we're looking at this as a global problem as it's framed here, is very challenging. So some might say, well, they're providing a good for the entire world, this country, by unilaterally implementing SRM. And it provides a benefit for everyone. But where you have distributional impacts and benefits, for example, some northern countries may actually want warming. It certainly opens up some economic opportunities and so forth. Where countries don't agree, then you have a real juggernaut of an issue to solve with governance. And the current international legal system isn't set up well for dealing with this problem, because any sort of multilateral agreement requires the consent of states. And so they all basically, it would be very difficult, given all of the controversy and differential interests, to come up with an agreement that suits all states. And I would use climate change as a proxy for thinking about this problem. So given the sort of difficulties we've had since, well, the late 80s on coming to some workable framework for reducing emissions and also for adaptation at the international level, this, I think, can only be predicted as being like extended to issues such as SRM, and the governance problem is also a bit different and potentially more challenging internationally. I
imagine. Thank you, Anna Maria. Very interesting. Thelma or Doug, anything to add on that?
Well, maybe I can have a go here. Obviously, I think we have already mentioned that as the question goes, that not all countries agree to do SRM tests and deployment. Most likely the countries do not know at this stage profoundly enough on the implications, as we mentioned, locally and regionally. And so there is a lot of uncertainty still. The laboratory tests that have been carried out and modeling approaches, so everybody says, well, we know the implications from modeling approaches or modeling results. There are several different models going on. So obviously, some countries may know more, other countries may know less. So we do need to think of the inclusive governance that Anna has mentioned in her presentation, the IPCC definition of governance, which is really a very inclusive governance, including the national, supranational governments, the civil society, the private sector. So you have everyone engaged into this. We also mention a lot in the IPCC now, the concerns that we have with the indigenous peoples, the local communities. So that might be really affected by some of these methods, right? So inclusiveness is a must here. So without us having a very clear international agreement and or complementary national institutions, the probability of us having unilateral testing or deployment of SRM is very much elevated, right? So this unilateral action could potentially result in international tension, conflict, distrust that could even compromise the physical feasibility of SRM or the costs associated to it. So we see that these things go together. We talk a lot about governance, the need of governance, not only governance of research, but of governance that, or regulatory frameworks that would potentially guide the testing on SRM methods, how and when. But maybe I would have a question to Anna. Anna, when we talk about this international law, I may be wrong here when I say that it obliges the government to protect and preserve the environment and to act in a precautionary manner in the face of scientific uncertainty. So I was sort of wanting to,
yeah,
sort of pushing you on to, am I right when I say it is mandatory that governments protect and preserve the environment? And, and how this could, in a sense, compromise all that we are talking about.
Well, there's a lot of, and I think the question maybe wasn't fully answered, at least on my part, which raises the issue of SRM tests and deployment occurring in a common space or over the high sea. So if we take the issue of a deployment over the high seas, then we're sort of starting to put a context around the legal questions of how might this be regulated. And so when we talk about the high seas, it's an area beyond national jurisdiction, which at present is mainly governed by the principle of the freedom of the high seas. And this includes the water column, but also the airspace above. And so, so at least within the UN Convention on the Law of the Sea, we have a particular framework. The question is whether a deployment would have an adverse effect on the marine environment. How do we even define marine environment? So is the atmosphere above the water column on the high seas even classified as a marine environment? Or are we talking more about a spatial concept? Does this better fit within the law of the atmosphere and the regime that applies there? In general, states have a due diligence obligation to prevent transboundary harm and also harm to the global commons. But there are a number of caveats to when this due diligence obligation would apply. And one of the issues here, as you point out, is the uncertainty. So, so where there are probable effects, and certainly that obligation is engaged, but the legal status of the precautionary principle, at least in customary international law, is not confirmed, at least by any international court or tribunal. And so it has likely only an emerging status. And so there's a lot of uncertainty regarding what the impacts might be from this kind of intervention. And so you can see how the legal framework is very contextual in terms of how you apply it, and all sorts of new questions and difficulties emerge when you're trying to apply existing legal principles. And there are certainly gaps that emerge in this regard. And so it demonstrates nicely the need for governance and clarification of how these norms might evolve to address this new situation, at least at the international level.
Thanks, Anna Maria. We've got about 4 minutes left. And one more question, but Doug, do you want to add anything to that, or should we jump to the final question?
Yeah, well, I actually I think the final question sort of like builds on some of what was just said.
Yeah, it does.
And so two things that I think might be worth clarifying a little bit relative to both of those last two questions. One is, when you're balancing the risks from climate change and the risks or benefits from SRM deployment, part of the problem is that it's not like, risk is not one dimensional. There's a whole bag of different things. And so SRM might increase some risks and decrease other risks. On the whole, I would say it's a pretty safe statement to say that if you don't change it, if you assume that the choice to use SRM does not itself affect the amount of emissions, then SRM probably reduces uncertainty considerably in most, but not all impacts. That is to say, we have a lot more confidence in what a 1 or 1.5 degree world looks like than we do in what a 3 degree world looks like. And so if you're like to really naively take a precautionary approach might suggest that actually we ought to be deploying some SRM. Not today, because we don't know enough today, but it is certainly plausible that a precautionary type view could push towards deployment, not away from it. But different people are going to, they're going to be looking at different subsets of risks, right? Different baskets of risks. The one other thing I thought just might be useful to clarify in the previous question about testing and deployment is there's not really such a thing as a test. There's two types of uncertainties. There's like process uncertainties in our models. We don't really understand cloud aerosol interactions. We don't really understand aerosol microphysics or something like that. Those are like really small scale processes that we need to resolve. And then there's the uncertainty in the overall climate response. How does it change precipitation patterns and stuff? There is no such thing as a test to resolve the latter. We will always be predicting climate responses using a model until we actually, in fact, actually probably until we've been deploying for like 20 years. So, when you're thinking about tests versus deployment, there's like an enormous, if you're thinking of tests as like all outdoor experiments, the sorts of things that are actually outdoor experiments per se versus deployment, there's like vast scale separation between that and anything that would be deployment. Just thought that was worth throwing in there to clarify.
Those additional clarifications. Unfortunately, folks, we've run out of time. We could carry on and on. It's a fascinating topic, very complex. And my thanks to our three wonderful speakers here, Anna Maria Hubert up in Canada, and Thelma Krug down in Brazil, and Zog in the USA. If you're a bit baffled or a bit lost, have no fear. There's plenty of other resources available on the C2G website, and do sign up for updates. There are many other C2GLearn events coming up, and you can go to www.c2g2.net/C2GLearn to find out more. After this webinar closes, you'll see a survey pop up. We encourage you to share your comments with us for future events, and any thoughts you had on the speakers and what was discussed today. And once again, thanks very much to you, our participants, for joining us, although a few have left now, and to our speakers and to my colleagues in the background, and look forward to seeing you next time.